Good morning, everyone, and thanks for logging on. My name is Alysa Gauci, and I'm a graduate research associate at Ohio State. And today we'll be diving into utilizing yield monitor data for on-farm research trials. So to begin with, we all know the endless possibilities there are with on-farm research. On previous AgTech Tuesday webinars and throughout the eFields book, we see seeding rate trials, fertilizer rate trials, nutrient management, you pretty much name it. Although there is a lot of diversity among these studies, one commonality between them is utilizing yield data, especially from yield monitors. As we know, yield monitors are one of the most used technologies in precision agriculture and in on-farm research. However, aside from calibration, there is really limited information on setting up on-farm studies that use this data as a response variable. And when it comes to proper experimental design, should blocks, strips, or even individual yield points be used? Are the assumptions and conclusions we're making based off of the yield data accurate to what's truly happening out in the field? As you can see, there are several questions regarding this topic, but overall, one of the most important ones, and also what this project aims to answer, is what scale can yield monitor data be used to support on-farm research? So like I mentioned, this project aims to test some of these questions and ultimately create some best management practices too. To do this, we had a 15-acre field out at the Western Agriculture Research Station in South Charleston to test some different plot lengths. We looked at 7 different lengths that ranged from one of the smallest plot sizes that's been used at 12.5 feet all the way up to 800 foot that was selected to simulate the natural variability within the field and to create intentional high and low yield differences that could be measured. The plots alternated with 0 and then 180 pounds of nitrogen per acre applied. So I know this looks a little overwhelming, but stay with me. This is what the original plot plan looked like, with high yield areas hoping to be in green where we applied nitrogen, and then the exact opposite for gray, so no nitrogen applied there. And luckily, this was transcribed pretty well, as you can see from this mid-season aerial shot that we got. Moving on, data collection was conducted with a field combine as well as a plot combine. We had 12 rows per pass. 8 of those rows was harvested by the field combine. The adjacent 2 was harvested by the plot combine. And then there was a buffer on either side of each treatment. The field combine was equipped with an 8-row corn head and 2 commercial yield monitors, and it ran the entire 1,000 feet at a constant 5 miles per hour. The plot combine also ran the entire 1,000 feet, but it did stop every 25 feet to collect an estimated weight. And for the smallest treatment, we did have to stop the plot combine every 12.5 foot to get data for those plots. And this was done with hopes to have an accurate yield estimate of each plot that could ultimately be compared back to what the yield monitors would report. Then we also measured the weight of each pass with the weigh wagon for those accumulated weights. So some results based off those accumulated weights from the yield monitors. This is plotted against what the weigh wagon recorded. This can be seen here. This is looking solely at the accumulated weights, not taking into consideration any of the treatments or any of those high or low yielding zones. This is simply an average per pass. As you can see, both yield monitors have nearly a 1-to-1 relationship when compared to what the weigh wagon reported. This was the first step in making some comparisons, but most importantly, it showed us that the accumulated amounts per pass can be accurate. But what about that point-to-point variation or even variation across the field? This was the next step, to dive a little bit deeper and consider some of these different treatment links. And that's what's shown here. Here we have the yield data for one of the 50-foot passes from the plot combine and from the case yield monitor. Notice how at the smaller treatment, the data doesn't really overlay too well. It's a little bit shifted. The yield monitor is picking up changes in yield, but not necessarily reporting similar yields to that of the plot combine. Like I mentioned, that's due to some of those shifts, and it is also important to note here that there's a little bit of overestimation from that yield monitor too. But as we increase those links, we did see the yield monitor data fit the yield estimates from the plot combine a little bit better. And an example of that can be seen here. This is one of the passes for the 200-foot treatments, and compared to the 50-foot plot we saw in the previous slide, the yield monitor picks up these yield differences going from a high yield zone to a low yield zone, and also estimates that yield a little bit more closely to what the plot combine reported. And these trends can be really seen on this next slide. So here we're looking at the normalized yield for each treatment length for the plot combine and for the case yield monitor for each of the high and low yielding zones. Theoretically, we would want that light green area that represents the plot combine data for the low yield zones to match the dark green that represents the yield monitor data. We want that data to match up almost exactly, if not very closely. And then the same goes for the gray areas that represent the high yield zones for each. However, at about 12.5 foot and even 25 foot, there is virtually no difference reported from the yield monitor. It's estimating that the high and low yield zones are the same, which we know that's not correct. As we saw in the previous slides, those differences are picked up around 50 foot, but not really representing what the yield is at that point, or at those different points. It's not until after 100 feet that the data starts to match in terms of recognizing high and low yield zones, and also reporting these estimates similar to what we saw with the plot combine data. And so this was looking just at the case data. There was another yield monitor used in the study. And so here we see a very similar pattern with the precision planting yield monitor, that at 12.5 and 25 feet, the yield differences are not detected by the yield monitor. And even here, we also see some differences start to be recorded at 50 foot, but it's not until the much larger distances where the yield monitor data begins to closely match what we saw from the plot combine data. So I know that was a lot of information thrown at you in a pretty short time, but just to wrap up with a couple last points. It's important to note that if you already are, or if you're considering conducting on-farm research, you can see that it is critical to have enough length and a sufficient amount of yield points to be able to use that data that you're getting and ultimately have an accurate representation of what's going on in the field. Without that, you begin to question the effects of the treatments applied and the conclusions you're able to draw. It's also important to mention that this project is ongoing, and there are still several more steps and data analysis that needs to be conducted. But very preliminary, it's looking like this minimum length we've been talking about is going to be around that 200 to 400 foot range. And at the end of the project, the goal is to have a minimum length to recommend for conducting on-farm research trials. And looking forward, this study is going to be replicated in 2021, again using corn. We'll also be looking at the effects of varying combine speed and looking at those results. As mentioned previously, all this data was captured by running a consistent 5 miles per hour. So it'll be really interesting to see how varying ground speed will impact those results. And overall, just really excited to be able to begin another year of data analysis, data collection, research. And so that's all I had for today. Thank you for your time. Here's my contact information. Feel free to reach out with any questions or any feedback. I'm more than happy to discuss this project in more depth. Thank you.